Hello everyone, today we're going to be solving for average speed and average velocity. Coming right up. The question is, if I go to my friend's house with a constant speed of 30 kilometers per hour and I come back to my house with a constant speed of 50 kilometers per hour, what is the average speed and average velocity of the entire trip? Let's find out. So in this video, we're trying to calculate the average speed and average velocity of the entire trip that I made if I go from my house to my friend's house with a constant velocity of 30 kilometers per hour, and then I come back to my house with 50 kilometers per hour. My average speed, well, it would be tempting to say that my average speed is just my constant speed number 1 plus my constant speed 2, which is going there, coming back, over 2. But this is wrong. Why? Because the definition of our average speed, which I'm going to say is the average, equals to the entire distance of my trip over the entire time. So we have to first find these two variables to calculate for my average speed. What is my entire distance? Let's say going from my house to my friend's house, we're gonna call it D, and coming back, it's also the same D because it's the exact same distance both ways, right? So my entire distance equals to D plus D or 2D. So that's for the first variable. Well, let's first calculate what time is. If I move my time over there, so I can get what time equals to. So time equals to, we know is D over my velocity or my speed in this case. So my time going from my house to my friend's house, it's equal, so now we're trying to do the total, is equal to D over this constant speed, which we can call V in this case. And my entire time from my friend's house to my house equals to the same distance over, and let's call this constant speed U. So just gonna put the variables here so we have them also. U. So we know they're different. So now let's get a common denominator here so it's easier for us to calculate at the end everything. Common denominator is just gonna be V times U, and we have du plus dv, which, well, we'll see later. So let's get my two solved variables now into this equation and see what we get. So my V average, which is the speed, remember not the velocity yet, we're doing the speed, equals to, well, my 2D at the top, just plugging this in, over my time, which is du plus dv, and then because this is just over, it multiplies at the top, times vu. That's equal to 2dvu over du plus dv. Since I have the everywhere, I can just delete those. So this is my equation. The really cool thing about getting this equation is that I do know my two variables. I know that V equals to 30 kilometers per hour, and I know that U equals to 50 kilometers per hour. So I don't need any distance, I don't need any time anymore. I got it down to my two constant velocities. So now let's solve for them. So once you solve for this, you're going to get 37.50 kilometers per hour. That's actually your average speed. of this entire trip. Not this, because in this case, if you were to solve for this, you will get 80 over 2, which is 40 kilometers per hour. It's close, but it's not the actual response. The right response is 37.5. So now let's do average velocity. What is our definition for average velocity? So for velocity, to differentiate from speed, I'm just going to put a little arrow at the top that shows me, well, it is a vector, average. So my average velocity is actually the change in displacement, which I'm going to call x. Now you might have a different notation for that, but I do usually call it x, but that's just a change in displacement over the change in time of the entire trip. So that's actually just equal to my x final minus my x initial. That's my final position minus my initial position. And the same thing with time. My t final minus t initial. Well, let's start with the first variable here. If I am in my house and I go to my friend's house, and then I come back to my house, I want to know the average velocity of the entire trip, when I go there and when I come back. That means that my x initial is my house, but then I came back to my house to end my trip. So my x final is also my house. That means that my change in displacement is my, let's say, my house, just gonna put it like that, minus my own house. So that's just 0. So then there's no point of getting the time because it's just 0. 0 over anything is 0. So my average velocity in this case is just 0. So to summarize what we just did, all you have to do in this type of problems is go back to your original equation, the one that mentions that average speed equals to your entire distance over your total time of your trip. Same thing with the average velocity, you have to find your change in displacement over your change in time. And then once you figure out your two variables, then you should be able to find your average velocity. If you have any questions, please just let me know.